Hello students, welcome to Karmay Bharao Patil Vidyalaya and Junior College of Science, Sarola Kasar. On behalf of the online lecture series is conducted by Rayesh Shikshan Samstha, Northern Region Ahmednagar. Myself, Murumkar SS. According to the new syllabus, here I am going to teach the chapter Ionic Equilibria. For this chapter, weightage is a 4 and 6. That is 4 marks without option and 6 marks with option. In this chapter, we have to study the introduction about the ionic equilibria, definition of ionic equilibria, then electrolytes and its classification, degree of dissociations, and acids and bases. Let us start the definition of ionic equilibria. The definition of ionic equilibria is that the equilibrium between ionized and unionized molecules is called as ionic equilibrium. Then chemical equilibrium. In the last year in L-1 science, we have studied the definition of chemical equilibrium. For that, consider the reversible chemical reaction. The reversible chemical reaction is a plus B, it gives C plus D, where A and B are the reactants and C and D are the products. Whenever this A and B is converted into C and D, this reaction is called as the rate of forward reaction, and again this C and D gives the reactant. That means what? A and B are called as the rate of reverse reaction, and therefore the rate of reverse reaction and rate of forward reaction and rate of reverse reaction are equal is called as the chemical equilibrium. So according to this, the equilibrium is a state of system in which rate of forward reaction is equal to the rate of reverse reaction, that is RF is equal to RR, where RF is the rate of forward reaction and RR is the rate of reverse reaction. This equilibrium proceeds by two arrows. Which one? That is the forward arrow. This is what? Forward arrow. This is what? This is the backward arrow. It is also called as a reverse arrow. That means equilibrium proceeds by two arrows. This is the forward arrow and this is what? A reverse arrow. Then equilibrium, ionic equilibria exist in ions. What is meant by ions? Any charged species are called as the ions. Here ions with positive charge is called as the cations and ions with negative charge are called as the anions. That means what? Cation carries positive charge and anion carries negative charge. Here the examples for the ionic equilibria, that is the equilibrium established between unionized species and ionized species. That means here Ba is a unionized species and B plus aqueous and A minus aqueous are the ionized species. And then equilibrium established between this unionized species and ionized species is called as the ionic equilibria. That means here the equilibrium exists in between ionized and unionized species is called ionic equilibria. And this equilibrium is a dynamic process, or it is a dynamic in nature. Then these acids and bases when dissolves in water, it undergoes what? Ionization. While salt dissolved in water, it undergoes what? Dissociation. But in these both cases, the ions are formed. In the both cases, ions are formed in water. Therefore, here what? There is 4 criteria. That is these are the 4 examples behind what? Ionic equilibria. The ions and unionized water molecules, like this is unionized water molecule, and here ionized water molecule, that means H plus OH minus. This H2O dissociate into H plus OH minus. This H plus and OH minus are the ionized molecules and H2 are the unionized molecules. Then ionization of weak acids and weak bases. Ionization of weak acids and weak bases. That means what? Weak acid like such as acetic acid CS3COOH. It dissociates into H plus acetatine. Then weak base like NH4OH, it dissociates into NH4 plus OH minus ion, and the reaction between ions of the salt and ions of the water. And fourth one is a dissociation of salts and water. Next point, to know about the ionic equilibria, there are some important terms like electrolytes and non-electrolytes. What is meant by electrolytes? The substance which conduct the electricity in its aqueous solution is called as the electrolytes. The substance which conduct the electricity in its aqueous solution is called electrolytes. Or it can also be defined as the substance which splits into positive and negative ions are called as the electrolytes. Those substances which splits into positive and negative ions are called as the electrolytes. Example for the electrolytes are NaCl, copper sulfate, barium hydroxide. Here NaCl dissociate into Na plus Cl minus, Na plus aqueous plus Cl minus aqueous. This is the electrolytes, because what? This NaCl splits into positive and negative ions. Therefore, the NaCl is an example for electrolytes. Then non-electrolytes, the substance which do not conduct the electricity is called non-electrolytes. Example, urea, glucose, sucrose. This non-electrolyte can also be defined as the substance which does not split into positive and negative ions is called non-electrolyte. An example for the non-electrolytes are urea, glucose, sucrose, because they do not split into positive and negative ions. This is about the electrolytes and non-electrolytes. Then classification for the electrolytes. What are those classifications? These electrolytes are classified into strong electrolytes and weak electrolytes. This is the strong electrolytes and weak electrolytes. Here, this what is meant by strong electrolytes? The electrolytes are ionized completely or almost completely are called strong electrolytes. Example, Ba, it dissociates into B plus A minus aqueous. Here BH is a strong electrolyte, so it dissociates completely and represented by the single arrow. Other examples for the strong electrolytes are strong acids, strong base, and salts, like salt of strong acids and strong base, that is NaCl. That is NaCl is the salt of strong acid and strong base. The strong acids like HCl, H2SO4, and HNO3. HCl hydrochloric acid, H2SO4 sulfuric acid, HNO3 nitric acid. This strong acid dissociate completely, so it is the example for the strong electrolyte. Then strong base, it also dissociate completely in its aqueous solution, so it is also example for the strong electrolyte. Then next, weak electrolyte. What is meant by weak electrolyte? The substance which ionizes to a small extent in its aqueous solution is called weak electrolytes. Suppose Ba is a weak electrolyte, so it dissociates partially and gives the B plus aqueous plus A minus aqueous and represented by the double arrow, because it dissociates partially or it dissociates in a small extent. So it is a example for the weak electrolyte. Other examples for the weak electrolyte like weak acids, weak bases, and salt for the weak acids and weak bases. What is the example for the weak acid? HCN, hydrogen cyanide, and acetic acid. This is the example for the weak acid and also example for the weak electrolyte, because it dissociates in a small extent. Then the other example here, weak electrolyte dissociate only partially in its dilute solution. Therefore, ionization reaction there is represented as double arrow between ionized and unionized molecule. हे unionized molecule आहे, हे ionized molecule आहे, and Ba is a weak electrolyte आहे. Therefore, it partially ionizes and so represented by the double arrow. Then second example, that is weak base, ammonium hydroxide and calcium hydroxide. And त्याचबरोबर salts of Ammonium acetate is a salt for weak acid and weak base, and therefore it is also example for the weak electrolyte because it ionizes in a small extent. So it is example for the weak electrolyte. This is about the concept for the electrolytes. That means the electrolytes, non-electrolytes, and classification for the electrolytes like strong electrolyte and weak electrolyte. Then degree of dissociation. What is meant by degree of dissociation? The fraction of the total number of moles, fraction of the total number of moles of an electrolyte. कोणते electrolyte आहेत? That may be acids or base, undergoes dissociation in aqueous solutions at equilibrium is called degree of dissociation. What do you mean by degree of dissociation? The fraction of total number of moles of an electrolyte that may be acid or base undergoes dissociation in aqueous solution at equilibrium is called degree of dissociation, and this degree of dissociation is denoted by alpha. This alpha gives the strength of electrolyte. How will you calculate this alpha? This alpha, that is the degree of dissociation, is the ratio of number of moles dissociated at equilibrium to the total number of moles present. Then percent dissociation is equal to alpha into 100. If C is the molar concentration of electrolyte, then the equilibrium concentration of cations or anions is alpha into C mole per dm cube or decicubic meter. Suppose here total moles are 2. Out of these 2 moles, 0.1 mole get dissociated. Then what is the degree of dissociation? See here, according to this formula, total number of moles how much? 2. And the number of moles get dissociated 0.1. Therefore, alpha is equal to 0.1 upon 2, that is equal to 0.05 mole. Therefore, the fraction of dissociation is 0.05 mole per dm cube. That is, the alpha is a degree of dissociation and alpha is equal to 0.05 mole per dm cube. अशा प्रकारचा एक मार्कासाठी क्वेश्चन येऊ शकतो MCQ ला, नीट ला, CET ला. Then next, the factors affecting degree of dissociation. What are those factors? Here first factor, that is nature of solute, second one nature of solvent, third one temperature, and fourth is a concentration. Here the nature of solute, the degree of dissociation for the strong electrolyte, the degree of dissociation for strong electrolyte is equal to 1. Strong electrolyte कोणते आहेत? HCl, H2SO4 and NaOH, and that of the weak electrolyte is less than 1. म्हणजे alpha is less than 1. weak electrolyte कोणते आहेत? अमोनियम हायड्रॉक्साइड, ऍसिटिक ऍसिड आणि हायड्रोजन सायनाइड. याच्यातून ठरवायचं आपण काय? द degree of dissociation of strong electrolyte is more than the degree of is more than the weak electrolyte. That means for degree of dissociation of HCl is more than the NH4OH, that is hydrochloric acid is more than the ammonium hydroxide. Second one, nature of solvent. In polar solvent, value of alpha, that is degree of dissociation, is more than the non-polar solvent. That means what? The H2 is a polar solvent and benzene is a non-polar solvent. Therefore, the value of H2 is more than the benzene. Then the temperature. If degree of dissociation, if temperature increases, degree of dissociation also increases. Therefore, degree of dissociation is directly proportional to the temperature. Then concentration, the value of alpha, that is what? Value of degree of dissociation is inversely proportional to the concentration of the solution. That means what? The degree of dissociation increases, concentration decreases, and therefore the alpha is inversely proportional to the concentration. This is the factor. म्हणजे these are the factors which affect on the degree of dissociation. 2 मार्कासाठी क्वेश्चन येऊ शकतो. What are the factors affecting on the degree of dissociation, or enlist the factors affecting on the degree of dissociation. For 2 marks, this question will be asked. Next point, acids and bases. The acids and bases are familiar chemical compounds. Amla and amlari, the acids and bases which are useful in the family. Therefore, these are the familiar chemical compound. How it is a familiar compound? As acetic acid is found in vinegar, citric acid or citric acid is in lemons, magnesium hydroxide is a base which is used in as an antacid. Then ammonia in household cleaning products, and tartaric acid is present in the tamarind paste. म्हणजे काय, acetic acid, citric acid, magnesium hydroxide, acid as well as base are the familiar compound because it is found in this vinegar, lemons, antacid, cleaning products, and tamarind paste. These are the family. These are useful in the human life, human being. So these acids and bases are the familiar chemical compounds. This is about the today's lecture. Thanks for watching.